Hello everyone. Mic test. Hello to Jessica, Stephanie, Swislin, Rekha, Emily. Okay, I can hear myself. Alright then, welcome to today's Facebook Live session happening every Wednesday at 8 p.m. Brought to you by Maths Heuristics. So that page you saw earlier was our archives and the page to download the notes if you haven't done so already. Okay. So I know that all of you would have finished your SA1 by now. And that's what I'm going to be talking about today. How to analyze and break down the mistakes in the problem and what you can learn from them. So my name is Kevin Huang. I'm the curriculum specialist here at Maths Heuristics. So I've been working here since 2011 and hopefully there will be many more years to come. Okay. Hello to Emily, Jonas, Jeep, Ken, Joanne. Okay, then this is a photo that I just took today. Our courses are all based on the Mastering Heuristics series that my boss and mentor, Mr. Sani Tan, has written. Okay, then you'll be wondering why doesn't he show his face, because right now he's like very busy attending to several other projects. But he told me to take a good photo and send it to him, so hopefully this is good enough. Probably the exposure is too high here, but I have a few more. So all these 5 books have been written by Mr. Sani Tan since 2009. And the way I help him out is to read through the content and try to point out the mistakes. Of course, those before I joined the company shouldn't be considered. And moreover, right now we have already came up with apps to support the learning content inside the book, apps and web video. So the apps will teach this in a more interactive manner. And of course, you can see me shamelessly promoting my Facebook Live over here. Okay. So I'm not very photogenic in that sense, but I don't think I look that bad here. Okay, so let's talk about analyzing the SA1 paper. Okay, to deal with this, first of all, there are 3 levels of cognitive levels to be assessed in the PSLE, which I will talk about. It's already printed out in your notes. But here, what I want to mention is you need to have directed or deliberate effort on learning. Okay, when you deal with a problem, like let's say a student gets something wrong, we want to know and pinpoint why or where he or she went wrong. Okay, there's a lot of reasons why this could happen. Sometimes the child would think about area of circle as pi times radius. Then of course the whole thing is going to become wrong. Is it because they didn't remember the formula? Is it because they did a careless mistake? Is it because they took a piece of information that was meant for something else? Okay, so these are the 3 levels that we have: the knowledge, The first level will be on knowledge, the second level will be on comprehension, and the third level will be on higher order thinking problems. Hello, the unicorn and Sing Ling Leong, Mei Ling, Yuki, Bi Kok Kyong. Okay, hello to everyone who just joined in. So, okay, let me just get into the... It's not exactly a lesson also, but let me get these points across first. What is knowledge? Now, knowledge over here requires you to recall facts. Well, this is a bit too big. Recall facts, concepts, rules, and formula. Okay, it also requires you to perform straightforward computation, and it requires you to memorize a few formula. Okay, like that area of circle is pi times r times r. If you want to understand how it's derived and all that, you can also do that, but I would say that for primary level, this is enough. Okay? Memorization of formula. Okay, so this is for the knowledge component. Then what about comprehension? Comprehension requires you to interpret data, use a maths concept. Never see you before in person, but it's okay. Rule or formula in familiar situations. Okay, and this part requires practice. Then finally, the last one will be on higher order thinking skills. Now these are the problems that are typically found in... why like that? Okay, for higher order thinking skills, they would require you to analyze data, apply a maths concept, rule or formula in this is where it gets different, in complex or unfamiliar situations. Okay, so there's problems like this coming out in PSLE 2017, the ribbon question, PSLE 2018, there's this large box, small box question, and also the short candles and long candles question in 2018, paper 2. Okay, so all these would require heuristics and higher order thinking skills. So let me get into a few examples first. When you look at the problem that your child has issues with, where or what types of problems are they? So let me give you a few examples. These are not exhaustive. So the very first one that you would definitely see in most MCQs is the placeholder value. Now what is the value of 4 in this number 854,013? The answer is not 4. The answer here is 4,000. Oh, situation. Okay, you have to be able to get this at the snap of your fingertips. Okay, then the next one is on basic computation types. So this one is also assessing your knowledge and comprehension. 3/4 times 6, this will most likely be in a paper 1. So the way to do this is, you want to multiply out the numerators. 3 times 6 will give you 18, and the denominator will be 4. And after that, you want to remove off as many wholes as you can. So this will become 4 wholes and 2 out of 4, which simplifies down to 4 wholes and a half. Okay? Or you can also write it as 4.5 if there's no restriction in expressing your answer. Just leave it as a fraction or a decimal. Okay? So the third type is on routine procedure. Now this kind of problem is very common in paper 1 for the P5s. Okay, what is the area of this triangle here? Now let me talk a bit about triangles. If you saw my Facebook Live on spatial visualization, you would know that there's 3 ways to define a triangle's base and a height. So over here, there's also 3 ways to do it. So let's say that this is your base. Okay. If this were to be your base, where is your height? Now one thing that a lot of people tend to miss out and we all take for granted is that the height is perpendicular to the base. And it is the highest point relative to the base. And it has to be perpendicular. So if your base, okay, sorry, this one is supposed to be the other way around. This is 20, this is 12. So if this were to be your base and this were to be your height, then we can compute the answer. If the child does not know what is the base and what is the height, then this would require some luck on his part really. Okay, sometimes they may take half times 20 times 12, which is okay. But on the other hand, you also have half times 12 times 16, half times 20 times 16. So there's a 1/3 chance of getting it correct. These types of problems, you have to really know how to find the area of the triangle. Okay, and how to recognize your base and the height. These are very common at P5. And all these little precious marks is going to add up to something really big. So don't let them go to waste. So this would simply be half times 20 times 12 to give you 120. Okay? Well, I look so blur. Okay, you try to refresh your own screen. Okay. Sorry, this is supposed to be basic skill number 4. So there are these types of familiar word problems which you will see more often in paper 1 with the new format. So the way it goes is this. Lynn joins a club. She pays a membership fee of $45. She also pays $5.50 each time she books a tennis court. And she books the tennis court 30 times. So how much does she pay the club altogether? So here, you have to first be able to see that you have to pay that fixed membership fee of $45. Then, you would also need to pay $5.50 for 30 times. Then this would give you $165. Okay, you add that to the membership fee that you have to pay up front. You will get a total of $210. Okay, so all these are very basic skills that you need to pinpoint where they are getting wrong. If they are getting wrong over here, they are probably taking $45 and multiplying it by $5.50. There are certain students who are like that, I've seen before, because I'm teaching like a whole range of abilities of students. Some of them, they really don't know. They will just take any number and whack. It happens. Okay? So you have to be able to pinpoint them and probably bring them out for shopping. Because when I was young that time, I always go with my parents for grocery shopping. Then I always look for the best deals at the time. Okay? This would help them to appreciate on how these things are calculated. That's what I think. So let's talk about the higher order word problems. Where are they getting it wrong? So the first example is on spatial visualization, as you can tell. Now, let me go through a bit on how to solve problems. So this document is on Polia's 4-step approach to problem solving. I think they put it a lot better than myself. And the way it works is this. The first step to any problem is to define it and understand the problem. Okay? If you don't understand the problem, there is no way you can handle it. You will end up and take like 45 times 550 over here. Okay? If you don't understand what's going on. Then, okay, so for this, you have to learn the necessary underlying concepts. Okay? Who, what, when, where, how, all these things are important. So I don't want to spend too much time on this. The next thing is to devise a plan and plan out the appropriate heuristics to use to deal with these problems. Okay? You can either draw pictures, use a variable, be systematic, solve a simpler version of the problem first, guess and check, trial and error, look for a pattern or patterns and make a list. Now this is not done by a Singaporean, but nonetheless I find this document worth reading. Okay? Then after you have done that already, after you have planned out your moves, you want to carry out the plan and execute it. Okay? There's one very important thing that I always believe. How you practice is how you will execute. Okay, think about that for a moment. How you practice is how you will execute. If you practice it in a way that only you can understand, most likely during the exam, you are also going to write out in the same manner that only you can understand. And it's going to be very hard for the teachers to award you the marks accordingly. Okay? So you want to practice it deliberately. It can be a bit long-winded, but it's worth the trouble. How you practice is how you will execute. So spend time on deliberate practice. Okay? The next part here is on carrying out the plan already. The next part here is looking back, which is today's focus. There is a lot of there is a lot of methods inside the market right now. Some of them are okay, some of them hard to say. I don't wish to comment. But the main thing here is that you want to reflect back on how things can be done better. Okay, once you have a potential solution, you want to check and see if it works or not. Did you answer the question? Is your result reasonable? Okay, like for example, if they ask you how heavy am I? Okay, if you say something like 1000 kg, that can't be possible. Okay? Is your result reasonable? You want to double check everything, double check any computation, but most importantly, I think it's on reflecting. After the war is over, you want to think back on how things could have been done better and where to focus on to fight the next battle. Okay? So, there's a lot of reading over here. I suggest you go and download it. Google for Polia's problem solving model. Okay? So, the most important thing is, can this problem be generalized for more future problems? Okay, so over here, let me talk a bit about the heuristics the role of heuristics in primary maths. So it seems like there's a lot of heuristics advocated for the primary maths, 11 of them in fact. First one is on using a diagram or models, second one is on before and after scenarios, the third one is on acting it out, the fourth one is on systematic listing, looking for patterns, working backwards, guessing and checking, simplifying the problem, making supposition, solving part of the problem, and paraphrasing the problem. So it looks like there's a lot, but let me break it down to you. Okay. Okay, where is it? Using diagrams or models. This part, you may want to tabulate your information instead, which is what we use for before and after. Now for this is a pictorial approach that you will tend to do at P3 and P4. P5, first half of the year, they will focus on this, especially for those problems involving remainder. The second one is on before and after scenarios, and also we use tabulation for this. So certain problems is easier done with models, to be very honest with you. Probably next time I'll do one Facebook Live to show you. The third one, acting it out, is more for lower primary kids to fully appreciate the maths concept so that when they do it, they understand. Okay? The fourth one is on systematic listing, which you may need in for certain questions. There is no other way but to list out the possibilities. The fifth one is on looking for patterns. This part you have to know how to observe the changes between things. The sixth one is on working backwards. This part is applicable to several things, even in life. Like you want to go for a holiday, how much do you need to save up? Then you have to start cutting down on your expenses here and there. Where should you cut down? Things like that. Then the seventh one, guessing and checking. In maths and in life, there are certain things that are not immediately obvious because there is not enough information. So we just have to keep on trying and trying and trying until we find a way. But of course, there's better ways to do it. So over here, simplifying the problem, solving part of the problem, and paraphrasing the problem. These are things that we tend to do in the background. Okay, making supposition and guessing and checking are very much interconnected. There is the only mutually exclusive part for making supposition is, I would say, is like you want to suppose that the lowest common multiple between a certain distance is so and so. The distance between two towns has the lowest common multiple between the speeds. Things like that. So in effect, there's only a few things you really need to memorize. And like what I said, how you practice, because I always emphasize on these three things. How you practice is how you will execute. Okay? So in effect, in my opinion, there's not that many heuristics that you really need to memorize. Okay? Right. So with this in mind, let's talk about a few common problems that children face. The first one is on spatial visualization. Okay, now the figure below shows two identical quadrants and an equilateral triangle. Find the area of the shaded parts. So here they did not tell you that this is a square because they are not so interested in it. You want to identify out where your two quadrants are and where is your equilateral triangle. So of course, this part is rather obvious. These are the two quadrants. And this would be your equilateral triangle. Okay, so when you come to these types of questions where they tell you there is a special shape, you have to know the special properties that are attached to it. For example, for an equilateral triangle, all these three angles are 60 degrees. And secondly, all these red lengths are the same, which is also the same as these blue lengths here. So with this in mind, what else can we do? Now, because the radius of this quadrant is also the same as this length of the triangle, we can invert it over here. Just imagine that we draw out a triangle like this. This inverted triangle will have the same length as this because it is the radius of the circle. So remember, what is the radius of the circle? Is from the center point all the way to the circumference. Okay? So once we have this, it is clear that we can say that this part can be moved down over here. Okay, if we are to move this over here, it would fit in nicely. Okay, and if we do this, then this angle would also be 60 degrees. So remember, recall what this is about. This is on rearranging of parts. Certain questions require you to do this in order for you to solve, because you want to rearrange them in a way that you can use the known formula to solve. So if we do this, we end up with a circle. No, not really a circle. We end up with 120 degrees of a circle. So what is the fraction of this circle then? It would have to be 120 degrees over 360 degrees. And then the area of the circle itself will be times pi, 22 out of 7, times radius, 21, times radius, 21. And this would give you 462. Okay, maybe for clarity, let me use this units over here. Okay, and this would be your answer. I like your comment. We spend more love and likes to make it more positive. Okay, so this is the whole idea here. Okay. If you try to solve this by conventional means, probably you can get it. Never really thought of it that deeply. But the best way to solve certain problems is to rearrange it and restate the problem. Okay, if you got it, please spam the like button. Okay. So the next one, guided example 2. So let's read out the problem first and we try to figure out what this is. Now you have 3 bulbs in a shop. Okay, one bulb lights up every 4 minutes, another bulb lights up every 8 minutes, and the third bulb lights up every 11 minutes. Okay, wait. Okay. Why is it 120 degrees out of 360 degrees? Because if you are to look at a circle like this, okay, angles about a point would add up to 360 degrees. So if this over here is 120 degrees, this would mean to say that hang on, something like this. This would mean to say that 1/3 of the circle is present. Okay? So that is the main reasoning. Okay. Okay, so I guess I have to move on to number 2 now. Now there are 3 light bulbs in a shop. One bulb lights up every 4 minutes, another bulb lights up every 8 minutes, and the third bulb lights up every 11 minutes. So all the light bulbs light up together when Ali walked into the shop. How many times will he see at least 2 light up together if he was in the shop for 3/4 of an hour? So first things first, just change this time into the same units as this. Change all this into minutes. Now 3/4 of an hour. There are some students who never do the topic of time for a very long time, pun intended, and they think that this is 75 minutes. Okay? Some of them will think it this way because they are thinking about the base of 100. So you have to be clear about what this is. 1 hour is 60 minutes. So once you have defined it out clearly like this, it is the chances of making mistakes will be greatly reduced. Now you can see that this would have to be 45 minutes. Okay, once you compute this out. So once you see this, you can say that if you try to find out at least 2 light bulbs lighting up together by lowest common multiple, congratulations, you're going to get it wrong. Okay, for this, there is no easy way, at least not that I've thought of, but to do systematic listing. Probably there's some number theory behind it I haven't thought of or come across. So this is a heuristic that you have to know. Okay, so we can model the lighting up every 4 minutes, every 8 minutes, and every 11 minutes. So when all the light bulbs light up together, now this part is important, when they walk into the shop. Then, at the 0 timing, they would all start to flash every 4 minutes for this, flash every 8 minutes for this, flash every 11 minutes for this. So then, this would, okay, just list out the multiples of 4 until you've reached the 45-minute limit. So this would be 4, 8, 12, 16, 20. Just keep on adding the 4s to it. Then you see that once you hit 44, if you try to list out another number, this exceeds the 45-minute mark. So do not consider it. Okay? Yeah, multiples, because it flashes every 4 minutes. So 4 minutes later, this guy will flash. 4 minutes later, he will flash again. 4 minutes later, he will flash again. 4 minutes later, he will flash again. So this represents 16 minutes after all the light bulbs light up together. Okay, so okay, wait. Okay, some of you got the answer already. The other one is 8, 16, 24, 32, 40, and if you try to list out one more, it exceeds the 45-minute mark. Okay, then the last one will be over here. 11, 22, 33, and 44. Okay, so here we want to circle those times that they flash together, when you have at least 2 bulbs flashing together. So be very careful about this. Write it out on a separate number over here. Then you see that next time two of them flash together is 16. The next time two of them flash together is 24. Next one will be 32. And the next one here will be 40. The last one will be 44 over here. Okay, so there are 6 times that they flash together. Then the next question is, do you count this portion or not? All the light bulbs flash together when Ali walked into the shop. Think about it for a moment. So of course, I guess now there is less emphasis on the English component, but I purposely use this question to make you think for a while first. Do you count this instance when he walked into the shop and all the light bulbs light up together? It's okay, I'm used to angry faces. Thank you all for speaking out for me. But anyway, the answer is yes, you have to count this in. Okay, you have to count you have to include the time when all bulbs, okay, you want to include this first time. Because after he walked into the shop already, then he flashed. He would have seen it. He would have seen all 3 of them flash together. Okay. No, I'm not very sad. I'm just a bit sick today. Okay, you're welcome, Gil. I'm glad to hear that. Okay. Okay, so let's move on to number 3. Do you understand why is it 7 rather than 6? That's the more important thing. Certain questions you have to read quite carefully about the premises. Like for example, if you are sharing, if you share with your friends versus if you share among friends. Okay, I can't recall the specific example offhand, but there are those problems where it involves this particular person sharing a number of sweets together with her friends. You have to include that person as well. Okay, so this part plays a part. But what I observe is that there is a de-emphasis on the trickiness based on language, because I don't think it's that fair to assess a child's mathematical ability based on his language ability. You know what I'm saying? Okay, yeah, I will. So this part you have to be careful. Okay. But what I think, if the schools are still testing these types of questions, they have good intentions for doing that. That's what I believe. Now let's go on to number 3. Okay, what digit here? What will be the digit inside the tens place? So this here is on pattern recognition. Okay, you don't expect the child to be pressing the calculator all the way from 81 to 1. Although that can be done, but please don't do that as your first attempt. Okay? So, okay, over here, be very careful here. Some of you got one part correct. Okay? Now the way to do this is you want to try to look for a pattern. How does this work? It goes from 81, then it changes to minus 80. Then we add 71 to it, minus 78 plus 77 minus 76 plus 75 minus 74, and so on. So let's try to restate this in another way. If you group them up in a way that is easy to calculate, the most intuitive part would be 81 minus 8. Then this would give you a 1. The next one here is plus 79 minus 78. There will be another 1 over here. There will be another 1 over here, and so on. So this will continue on all the way through until here. So before this minus 2, what should this number have been? It should be a plus 3. Okay, you have to be able to recognize the patterns over here. And then finally, there is a plus 1. So, based on this, my next question is this. How many 1s are there going to be? You can see that from 81 to this 2 over here, there has to be there are 80 numbers. Okay, you want to take 81 minus 2 plus 1. The way to do it is 81 minus 2 plus 1 to get 80. Okay? No, it's not 40. So over here, be very careful. A lot of you got the idea and can execute. So you say that you want to take 80 divided by 2 because you pair up all the numbers together. So you get 40 over here. All these would give you a 40. Then you have this 1 over here. Then some of you write 40 plus 1 to give you 41. And this is what some of you would do. You write here your answer is 41 or your answer is 40. No, be very, very careful. Here they say that the digit in the tens place. They are looking for that specific digit alone. They are not looking for the digit's value, but rather that digit alone. So the answer has to be 4. Okay? Hello, Audrey. Is there someone spamming? I don't really see it. Okay. Yeah, the answer is 4. They want specifically only the digit. Okay. Key confusion alert here. Digit only, not the digits value. Okay? And more specifically, not the actual number. Yeah. Okay, got it. Yeah, yeet. Okay, number 4. Let's go on to number 4. Now, Anthony and Gabriel received some money on Sunday. On Monday, Anthony spent $65, and as a result, Anthony would have twice as much money as Gabriel. On Tuesday, Gabriel received $30 from his father. Then the ratio of the amount of money Gabriel had to that of Anthony became 1:2. Okay, here there is something missing. I think, is it because of the black background? Yeah, I'm not too sure. But the last part here says find the amount of money each of them had on Sunday. Okay, I'll probably upload a newer version for this. So, right, let's go. So as you can tell, there are two actions over here. There are two changes, two actions, which means to say that this will be a before and after problem. And not only that, it also involves one more heuristic on working backwards, because your end result here is known. Okay, so let's define what we have first. This is our before, there is a change, there is an after. Another change and another after. Gabriel became 1, Anthony became 2. Okay, so let's draw out the table first and tabulate the information. Of course, you can use models for this. As well. But this is more efficient. You can definitely use models for this. That one I leave it to you to explore. Okay, so between A and G, let's start with what we know. We know that Anthony spent $65 over here. There was no change for Gabriel. Then we also know that Anthony would have twice as much money as Gabriel. Secondly, we know that on Tuesday, Gabriel received $30 from the dad. Gabriel to Anthony became 1:2. So again, be very careful on allocating or assigning your units. Okay? So find the amount that each of them had on Sunday. So to deal with this problem, after we have defined the entire problem, we want to try to make something the same first whenever possible. Okay, you want to, there are certain priorities that can be done. Okay, like for example, you have to look for a repeated identity first whenever possible. When this is not possible, then we just have to use units and parts. Okay, but over here there is a repeated identity. That repeated identity can be found within this box over here. Okay, so you can see that this tree represents the number of blocks that A has. At the same time, he also has got two big blocks over here. So you all have to understand what all these numbers represent. Okay, you see that this is 1 and this is 1. Then you'll be wondering why this 1 plus 30 will still give you back 1. Okay, let me just draw out the model to reconcile this portion. Okay, if you're first after, your second after. Excuse me. Well, not enough space. Okay, you have your first after with A and G, your second after with A and G. Okay, 3 blocks and 1 block for Gabriel. Now, there is no change for Anthony at this point. Okay, so you have to understand what your ratio's been, because these are very, very core concepts that will be tested, and they will be using a lot also. So this becomes 1 big block and this becomes 2 big blocks for A. You know what I'm saying? Therefore, we can say that because there is no change for A, these two are equal, you want to make them the same. So we times this by 2, we times this by 3. Get them to the lowest common multiple. So this would become 6 units. This would become 2 units. This would become 3 units. This would become 6 units. Okay, in the model form, what are we doing? We are cutting these two, the A and this A over here, into 6 blocks. Because when we do it this way, they are all in the same unit now. Okay, these are certain techniques that you need to have at your fingertips. You always need to be thinking about making them the same, looking for the repeated identity. Okay? So once we got that ready, we can now say that we can now evaluate and say that the value of 1 unit over here has to be 30. The change in units has to be the same as the change in value. So once we got that ready, we know that Gabriel has got 2 units here. 2 units will be 60. So if he has got $60 here, if we have to trace this back, this will also be $60. Okay, maybe I leave out the units for this. And as for Anthony, he spent $65 and then he had this amount. Okay? So 6 units here will be 180. If you have 180 remaining after spending $65, when you trace this back, you must have had 180 plus 65 to give you 245. Okay, so then the amount that each of them had on Sunday, the answer here for A would be Anthony would be $245 and Gabriel would be $60. Okay. Okay, so I've come to the end of my presentation. Thank you for having me. Generally speaking, I'll just ignore those who give angry faces. That's their opinion. If I try to get everyone to like me, I'll end up to be the most popular dead man in town. Okay, so I'm okay with it. Yeah, don't worry about it. I'll be fine. This sickness is... It often happens in May, when the weather gets a bit too hot. Yeah. So anyway, I hope you've enjoyed it. Okay, so recap on this. You can quote me on this. Wait, where is it? Where is the thing? Where did I write it? Very, very important thing. How you practice is how you will execute. So make a deliberate effort in practicing. Secondly, over here, you want to analyze and break down which are the parts that your child is having issues with. Is it a knowledge issue? If it is like recognizing the area of a triangle issue, then we just keep on giving them problems based on that until they get this idea, this formula. Okay? Comprehension, that part you have to keep on asking them, bring them out to go and walk and all that. Then higher order thinking skills, you want to read up a bit on the 4 main principles. You don't need to go too far, but you need to go and understand the 4 main principles of problem solving. Understand the problem, devise a plan, carry out the plan, and think back. Okay? Devising a plan usually revolves around the heuristics. And finally, okay, for this directed and deliberate practice on learning, we have our June holiday workshops for 2009 that you can check out over here. That's heuristics.com/schedule. Okay? You're welcome. So there's a lot of courses that you can take a look. Zoom in to those things that your child needs help in. Our workshops are specifically designed to tackle these problems in isolation. So it won't be like one whole workshop where you come and learn several things. You just come and learn those things that you need to reinforce on. Okay? So some of these programs, I say some because there are some of them without books. Okay, some of these programs have got books, apps, and web video support for them. You can take a look over here. Okay? Then thank you for your continuous support. We'll be taking a break for this June holiday. And Selamat Hari Raya to all our Muslim friends as well on the next Wednesday. Okay? Our Facebook Live will resume on the 19th of June. Okay? I'm grateful to have an audience, to be very honest with you. Okay, so anyway, if you have questions for me, I'll take them now. Alright? Yeah, thank you, Yuki. No, I'll be fine. This happens quite often. It happens like around May. This cough often happens because of the extreme weather change. Then due to climate change, I think it got a lot more pronounced. Okay, thank you for your well wishes. Okay, so thank you for all your continuous support. I really appreciate it. We'll see you all soon on 19th of June. Good night.